Let's have a look at different order systems. So the different orders has got to do with the response time from the input to the output of the system. So the first system we're going to be looking at is a Zeroth-Order Instrument. Okay, so this is where you're able to sort of see the result immediately. Okay. A good example would be in terms of a variable resistor. If you change the resistance, you would be able to see the result immediately. What you could also be looking at is like a switch. Let me spell that correctly. Switch. So when the switch gets activated, it will respond immediately. You'll be able to see a light going on immediately. Okay, then there's what's known as a first order system or instrument. Okay, so there is usually some or other delay, time that might be happening, and a typical example would be like a thermometer. Okay, so a thermometer, if you take it into account as to when you having to measure your body temperature, you take a thermometer, you stick it underneath your tongue, or it might be underneath your armpit, and you've got to wait. There's a certain duration you've got to wait before you're actually able to know what the temperature is. And it's usually about a minute or so that you've got to wait, and then you're able to sort of see what the result is. So the same issue happens with first order systems. There's a delay involved. Okay, so it is, you also might find that there is also an equation involved, and these equations could be in terms of, if you've got a electronic type of system, you're able to sort of calculate what the temperature is depending on voltages, but also it could be in terms of the rate of increase in temperature or decrease in temperature to be able to then identify what the actual temperature is. Okay, and then there's what's known as a second order system or instrument. And so a second order instrument is commonly used in a vehicle which has a cruise control system in it, and this is something that we'll be looking at where I'm driving a vehicle and you'll be able to sort of see that change is happening. So what we're going to be doing is, I want you to take note that there's two speedometers that are there's two dials that's on the dashboard. This one is the revolutions per minute, or the revs, and this is the speed indicator. Okay, and what I'm going to do is with this recording that I've done inside the car, I've put into like an artistic mode. So the definition is not necessarily high, but it allows you to see the with all the shadows in the vehicle and stuff, you're able to see the indicator over here for the revolutions, and you're able to see this indicator for the speed. And what's worthwhile to notice is that with the speed, it stays relatively constant. It does fluctuate a little bit, but it stays relatively constant because that's what we want, a speed control system. Yet you'll realize with the revolutions per minute, it starts increasing and decreasing depending on whether you're going uphill or whether you're on a straight line or straight road. And so this all will fluctuate depending on how much fuel is needed to be able to go to the engine to be able to keep this constant speed. New modern vehicles are able to have a cruise control feature in it, which allows you to keep a constant speed, and it uses some feedback control system to monitor the speed that you're going and what the desired speed is that you want. And when it gets activated, you'll realize that it's able to keep going at that speed. What's important to notice is the Rev Counter on the dials. You'll see that as the yields are approaching, the revs will start increasing, and it will start to try and compensate for the and keep that constant speed. And you can actually hear over there the sun increasing the revolutions of the engine. And so this constant speed of the car was done with the feedback control system. And there's different feedback control systems that you can find and you can have within a specific vehicle or mechatronic system. That's not what we're going to be focusing too much on. We're going to be looking at what's known as a proportional control or P control system, and then what we will do is see how that affects with the motion of the car. So the way that it looks at specifically for this proportional control system is that you've got some reference value that you want the vehicle to be going to. There's an adder over here, so it adds over there, it comes through, gets multiplied with a constant which we will refer to as Kp, and there will be some output represented over there. This output is monitored and it is subtracted at this adder. Okay, so let's look at an example to sort of see how it is. So we wanted to go at, let's say, 40 kilometers per hour. So that would be our reference point. And so as I'm busy going, I'm going on the road, it's going at 40 kilometers per hour, and then I start going up a hill. So as I go up a hill, obviously your speed is going to decrease of the vehicle. So suddenly now the output over here is indicated to be, let's say, roughly 35 kilometers per hour. Okay, so what's going to happen is it's going to say, okay, well, I'm getting 35 over here. Kp is just a constant value, and we're going to make that equal to 1. So what's going to happen is 35 kilometers per hour is going to come over here. It's going to come down. We're going to see over here, it's going to be reference minus your output. So this is going to be known as your error. Okay, and your error is going to be equal to 40 kilometers per hour minus 35. So that's equal to 5 kilometers per hour. So now that means that 5 kilometers per hour needs to be added to your output value to make it equal to 40 kilometers per hour. So your vehicle is going to increase the gas or the petrol or the fuel that's going to be going to the engine to be able to compensate for that, and it's therefore going to increase this then to plus 5, which is going to make it 40 kilometers per hour. Okay, so that's a very vague picture of what's going to happen. And with feedback control systems, you've got to take into account. So you might be at, let's say, 0 kilometers per hour, and now you want to be able to obtain your 40 kilometers per hour, which might be a point over there. So if you were going from a 0 kilometers per hour point, you would be increasing the speed. And with these proportional controllers, they often do overshoot your value that you want. And so you might find, depending on how much damping there is, something like this could happen. It could oscillate a little bit, and then eventually it will oscillate very small values at the speed you want it to be. And that's why you will see the speedometer, at least the speed of the vehicle, that went up and down slight values as you were going up and down a hill, to compensate or to be able to have that overshoot and undershoot happening, but it was around about 40 kilometers per hour all the way. And so this is what often happens. Now, you can go into more detail for this in terms of feedback controls and systems, which we're not going to go through, but this gives you a good idea in terms of how feedback control systems are used, what you're going to be doing, and how to actually implement this in the mechatronic system later on by looking at what your output is over here and feeding back into the input to compensate for any variances, and then to add, let's say, a certain input in terms of, like, let's say, more acceleration on the gas pedal to allow you to not more acceleration, but the accelerator you will push down, and the gas pedal will push down, and that will increase the speed, which then allows you to try and keep that 40 kilometers per hour value.